Okay, then let's have a look at question 1. We've got these 4 points A, B, C, D. The coordinates are mentioned here in the question. We need to find, first of all, the gradient of A to C, the first and the third point. Then we need to show that the equation of AC is this. Then we need to show BD is perpendicular to AC. And then we need the equation of BD. So these are the 4 things. I've written them all down. So we need to do a sketch first, don't we? So let's draw our y-axis, which I hopefully can draw a little bit better than that. So let's just draw that then. And let's draw our x-axis, like so. Y and 0. Let's mark off some of the points then. We've got to be careful here. We've got a 316, so put that one in first. It's very high up. So that's a 316. I can put that one there. And then B is 9 minus 1. So I can put that here, can't I? And that would be B, 9 minus 1. And then A minus 6, 4. And then up 4, which would be about here, wouldn't it? So that would be A, and that's minus 6, 4. And then lastly, we've got A, C, B. We need D minus 7, 11. And up 11. So I need to put it up here. About there. And this is D. And this is minus 7 and 11. So I'm just going to move that slightly because it might obstruct things. No, I'm going to try and grab it a bit better than that. Let's try and move most of it anyway. There's A. And I'll just tidy it up now. Okay, good. So there's A, there's D, there's C and B. Now the first thing then, let's do the first problem, the gradient of AC, A to C. So let's just sketch it in. So let's draw the line from here to here. Let's mark off underneath the slope. So there's the increase in X. It's a positive slope. There's the increase in Y. So gradient AD. So let's do number 1. Answer, gradient equals the increase in Y, this value here. So how much does it go up by? Well, it goes from 4 to 16, so that's an increase of 12. How much does it go along? Well, it goes from minus 6 up to 3, so that's an increase of 9. So the gradient then, the increase in Y is 12. It's positive gradient because it goes upwards, up 12 along 9. So the gradient is 4/3. Now the equation for AC, from A to C, well, we know the gradient and we know the points, don't we? The C point is 316, so part 2. So here, I'm going to write down y equals mx plus c, but straight away I'm going to put the gradient in for that line BC. And at C, which is the point 316, and put the value in. So the y value, this line goes through this point, so we can put in these x and y's and find out what c needs to be. So 16 equals then 4/3 of the x value, which is 3, plus c. And that implies, and I'm going to cut a long story short here, c, I'm reading from right to left, c equals 16. Move the 4 to be with the 16, becomes minus 4. So c equals 12. So y equals then, it's 4/3 is the gradient, x plus 12. There we are, there's part 2 done. Good, 4/3 x plus 12. Great. Now let's move over to part 3 and 4. Show that BD is perpendicular to AC. So part 3, let's put it over here. BD is perpendicular to AC. So we know the gradient of AC because we just worked that out. And now we need the gradient of BD, don't we? So that's the first thing to work out. Gradient BD equals, so let's go to the diagram and find out what BD gradient is. There's B and there's D. So we can put in a line across there. I'll put it in a different color so it's absolutely clear what we've got. So B down to D. And now we'll draw our little x and y heights to mark off the gradient. So a little triangle either above or below. will suffice to work out the increase in y's and x's. The slope is going downwards, so it's a negative gradient. The increase in y is negative, so this height here goes from 11 to minus 1, which is 12. And how far does it go along? Well, it goes from minus 7 on the x to 9 on the x. So total distance is 16. So we've got an increase of minus 12 over 16, haven't we? Minus 12 over 16, which equals minus 3/4. Divide by 4, top and bottom, you get minus 3/4. So here, 4/3 times minus 3/4. The gradient of the line AC and the gradient of the line BD, multiply them together, we should get minus 1. So yes, these are perpendicular. Part 4 then, so let's do that here. Put it in here. So now what do we need to show in part 4? We need the equation of BE. So gradient of BD, the equation of BD, I'll get it right in a minute, that shouldn't read BE. I've written it down wrong, I've just checked, and it's gradient BD. Okay, so we've got our gradient, equation of BD, so we've got our gradient of BD. So here, we've got y equals the gradient, minus 3/4, that's the m, x plus a c, the intercept value, you could call it c dashed if you wish, at b then, and the coordinate of b is 9 minus 1, so I'll write that down here. We could have put d in, but same difference really. So put the values in then, minus 1 here for y, minus 3/4, times 9, the x is 9, so put 9 in, plus c. So we get c equals then minus 1 plus 27 over 4. So 27 over 4, take 4 over 4 is 23 over 4. So what have we got then? We've got y equals minus 3/4 x plus c, which is 23 over 4. That's the equation of the line. Now we can move things around if we want, times by 4 all the way through. 4y equals minus 3x plus 23. And then we can also write it in the form of, move the 3x over, 3x plus the 4y that's already there, then move the 23 to be with them, and that will equal 0. So either of those two is fine as the equation of the line. Okay then, that's part 4 done of A. Good.